Okay, let's look at some of these questions. Like I say, best thing to do is draw a little diagram. So there's our little boat, there's the water, there's the bottom of the ocean, and the sound waves released by the boat and goes back up again. It's reflected off the kind of bottom of the ocean there. This is how boats can get an idea of how deep the ocean is, but it's also how they hunt for like schools of fish as well, and submarines if needs be. So the time for that to get down to the bottom and back again is 3 seconds. The speed of sound much faster in water because it's more dense than it is in air, and we're looking for a distance. Okay, you have a choice. You should get the same answer either way. We could work with this time and then divide the distance by 2 at the end, because the distance this 3 seconds will give us is distance to the bottom and back again. Or else I could divide that time by 2 at the start, which would give me that it takes 1.5 seconds to get down to the bottom of the ocean. Okay, we'll do it that way. So let's do speed equals distance divided by time. 1,500 equals distance divided by 1.5. Multiply both sides by 1.5, and that gives us that the distance to the bottom is, what's it, 2250 meters. Let me just check that in the calculator. Yeah, okay. Similar thing for question 2. Boat, seabed, sea, sound is fired down, back up again, and that takes a time of 0.4 seconds. Let's do it the other way. Let's just do speed equals distance divided by time and put the 0.4 in. 1,500 equals the distance divided by the time taken to get to the bottom and back again. So 1,500 times 0.4 equals d, which is 600 meters. But then we have to remember that the time was the time down and up, so this distance is the distance down and back up again. Therefore, at the end, we have to divide by 2, and that gives us 300 meters. Like I said, you could have done this by using the time as 0.2 at the start, divided by 2 at the beginning, divided by 2 at the end. Doesn't matter. You just need to do it somewhere. Next one. Bat emits a squeak and hears an echo from a wall after 0.2 seconds. How far away is the wall? So this is like bats see in the dark. They don't actually see in the dark, they hear in the dark. So we have our bat. There's our bat. It emits a click. Sound travels to the wall, back again. Time of 0.2 seconds. Speed is 340 meters per second. We want to know how far away the wall is. So let's do where we divide the time in half to begin with, because that will give us 0.1 seconds. This will be the time it takes to get from the bat to the wall. Then we can do speed equals distance divided by time. 340 equals distance divided by 0.1. So 340 multiplied by 0.1 equals our distance. So our distance is 34 meters. There's a good video. I'll see if I can dig it out and maybe put a little link into this document here as well. Some humans have been able to teach themselves how to do this. So dolphins can do this, bats can do it. It's called echolocation. But there was a story about a boy who lost his eyesight due to some form of cancer. And he was able to teach himself how to do this. He actually just made little clicky noises with his mouth and listen to the response. And from that, he was able to determine the kind of space around him. So humans can do this to a small extent, but bats and dolphins are much, much better at it.